Find AND probabilities with and without replacement. For example, suppose a bowl contains candies of various colors, 12 red, 8 blue, and 5 yellow. If 2 candies are chosen at random, find the probability that they are red if they are chosen A without replacement and A with replacement and B without replacement. Okay, well, the probability that the first candy is red and the second candy is red, if we follow our rule of AND probabilities, remember on contingency tables, everything kind of simplifies to just look into where the columns of a contingency table intersect. But when we're doing an AND probability without a contingency table, we have to use the multiplication rule, which just means we take the probability of the first event and we multiply that by the probability of the second event, given that the first event has already occurred. But here what we're doing is we're replacing the first candy before we draw the next one. So it doesn't make a difference. We have 2 events that are independent. So it doesn't make a difference that the first event's already occurred, so we just multiply each individual probability. Now it's going to be helpful that we know the total number of items here. So let's see, we have 12 red plus 8 blue and 5 yellow, a total of 25 candies here. So this would be 12 out of 25 times 12 out of 25. And there's going to be multiple ways you can type this into the calculator and get the correct answer, since it's multiplying fractions here. But this will work just fine. See, if I put parentheses around the individual fractions, I end up with the same answer. Order of operations really takes care of things for us here. 0.230. Okay, now the next one, we still want the probability that the first one is red and the second one is red, but we're not replacing the first one. So here, the probability that both are red is going to be the probability that the first one is red times the probability that the second one is red. But we didn't replace the first one, so now there's 11 red candies and only 24 remaining candies. So 12 out of 25 times 11 out of 24. So 0.22.